All right, today's lesson is going to be about how to solve a quadratic equation by factoring. In specific, this equation is going to be in standard form. So here we know that this is in standard form because it's in the form of y equals ax squared plus bx plus c. Here in this situation, a is equal to 1, b is equal to 7, and c is equal to 10. Whenever you have a equal to 1, you can use the following method to solve for x. You can just say 1 times 10. This is called the AC method because you multiply the first and the last. Well, 1 times 10 is equal to 10. So here we're going to put our graphic organizer. And we're going to find the two numbers that give me AC, which is 10, and give me B, which is 7. I want to get a B by adding. Whatever two numbers I find, I want to add them to get a 7. And I want to multiply those two numbers that I find to get a 10. But always start with the 10 first. Find the factors of 10 that will add up to a 7. So let me put that in our notes so that you can remember. Find the factors of 10 first. Okay. So here what we do is I know that 10 is the same thing as 1 times 10. I know that 2 times 5 gives me 10. I don't know of any other combinations. I could use -1 and -10, -2 and -5. But I don't have to do that because I'm going to get a sum of a positive number. So now here I want to look for the sum. Well, 1 plus 10 is 11. Oops, is 11. Not 7. I'm looking for a 7. 2 plus 5 gives me 7. That's the numbers. Those are the numbers I'm looking for. 2 and 5. So now what I'm going to do next is I'm going to get that 2 and that 5 and factor it out. I'm going to say y equals, that's a 5, x plus 2 and x plus 5. So I started with the standard form and I ended with the intercept form. Now, the intercept form has an advantage. I can let each one of the factors equal to 0 because the x-intercept, the solution to this quadratic equation is also your x-intercept. So I'm going to let y equal to 0 and then set each factor equal to 0. In other words, I'm going to say x plus 2 is equal to 0 and x plus 5 equal to 0. Then I'm going to solve for x. And here I'm going to use my set notation and say that x is -2 and also -5. So we went from the standard form to the intercept form to be able to find our x-intercepts. These are our x-intercepts found at y equal to 0. So we met the objective. The part that people will possibly get confused with is I'm going to take the same equation, and this time I'm not going to find the x-intercepts. This time I'm going to take the exact same equation, y equals x squared plus 7x plus 10, and find the y-intercept. Well, the y-intercept is found at x equal to 0. So I'm going to say y equals 0 squared plus 0, 7 times 0 plus 10. In other words, y equals 0 plus 0 plus 10. Or y equals 10. So when I look at the graph of this whole thing, the graph is going to pass the y-axis through the point 10. And it's going to have an x-intercept at -2. And another one at -5. So I know that my graph is going to look something like this. And here's a little bonus. The line of symmetry is going to fall right between those 2 points. So I'm going to go one in, one in. My y-intercept is going to fall right on that line at -3.5. So my graph is going to go down somewhere around here. This is an estimate. Oops, that wasn't quite symmetric. But this is supposed to be the line of symmetry. It's supposed to be. Okay. So be careful. We've got y-intercepts, which is this point right here. That's not the solution. And we've got x-intercepts, which are the solutions. So we solved a quadratic equation by factoring. We did that by taking a standard form, using the AC method. We created our graphic organizer and set each factor equal to 0. We just put the 2 and the 5 in place, set each factor equal to 0, and solved for x